Let's to start this section, parallel section number 5. That's the future of biorefineries. That I'm sure that's going to be very bright. So I would like to invite people here that Connie, McManus from FAPESP, Kees from Netherlands, please. Robert from the Consulate of Denmark, the Netherlands here. Paul Stuart from Canada. Fabian Schipfer from Austria. And João Carvalho from LNBR. Please. It's a pleasure to have all of you here. Biorefinery has 4 pillars, in my view. I learn a lot about you guys. We have to have feedstock, we have to have process, we have to have product and market. I think we have market. All the world are needing to, I don't like the word decarbonize, but defossilization. We are going to change carbon from fossil to renewable. If you eliminate the carbon, I don't know how you're going to survive, but a good idea is to replace it by renewable carbon. And for sure, we are able to manage well with the feedstock without any conflict with food production. That's something that you have already to think. We have to be very keen to develop a process to be able to use the biomass, and then to have products that society wants to use. Okay? That's the introduction, and I'm very happy to have all of you here. I will ask you to have a very short introduction, name and institution, and then we are going to make a small chance before the discussion itself is going to be a launching of a collaboration program between FAPESP and the NWO, that's Netherlands Dutch Agency of funding for research, and we are learning for them which are the objectives and the focus of this new camp. Please start with.
So good afternoon, everybody. My name is Connie McManus. I'm from FAPESP, and I'm responsible for national and international collaborations within the agency.
Paul Stuart, Envertus Consulting and Polytechnique Montreal, working mainly with the forest product sector on biorefinery strategies.
Is it working? Yes. My name is Robert Thijssen. I am the Counselor for Innovation, Technology and Science for the Netherlands here in Brazil, working for the Dutch government on bilateral collaboration in the area of science, technology and innovation.
Take this. Thank you. Hi, my name is Fabian Schipfer. I'm from Technische Universität Wien, the Technical University of Vienna. And I'm representing the Task 44 on flexibility and sysintegration of the IEA Bioenergy TCP.
Hello, my name is Kees. I'm working for the Netherlands Enterprise Agency, which is a department of the Ministry of Climate and Green Growth. And I'm here as the mission director of the Integrated Biorefineries mission.
Hello, everyone. My name is João Carvalho. I am a research at the Brazilian Biorenewable National Lab.
Thanks very much. I'm very proud to be here with so many important guys. And then I will give the floor to Connie and later on to Robert, or to Robert.
If we both go there, yes. And then it'll make things easier. Can you bring up the presentation, please? So, NWO, represented here by Robert, and FAPESP. No, that's not the correct one. It's one with Connie McManus on it. We're very pleased that after quite a while of negotiation that we're here to be able to launch a joint call between NWO and FAPESP on the future. Yes, that's the one. This is the... we're officially launching the call today on integrated biorefineries for a circular future. So the aim of the program is to increase collaboration between the Netherlands and Brazil in biorefinery design. We're both countries facing similar hurdles in bio-based economy transition, but we have complementary strengths. For example, the question that was taken up with the question of agriculture here in Brazil, that we don't have the problem of competition between agriculture and food production, and the agricultural waste, that both are major agricultural exporters, and this creates this abundant stock for the future of biorefineries. So the background for the call is that we're looking towards energy transition, with the chemical industry needing to shift from fossil to biomass, and looking towards a climate neutral society. Focused will be on research targeting sustainable biorefinery design, including zero waste and emissions, and integration to combine knowledge across several disciplines. One of the questions is that the call should have at least 3 areas in the team that is working, including the social sciences. Focus would be innovation, areas of interest, economic analysis, certification, modeling tools, research focus on the future and industrial scale implementation. So we have, So just to let you know, there are 2 areas. The first is the bio-based feedstock area, and the second is the conversion process, looking towards new production concepts for converting bio-based feedstocks, robust technologies, and looking towards more efficient processes and sustainable designs and modeling tools. And now I'll hand it over to you to give details of the call.
Let me see. This is the green one. Okay. Yes, I do apologize beforehand because I am not from NWO, so I am I'm the Councillor for Innovation here. But I'm very glad to be here on stage because, as Connie already said in her words, we have been working on this call for quite some time. We do have already a longer-standing history between the Netherlands and Brazil, and particularly between FAPESP and NWO in collaboration, also in other areas, but particularly also in the bio-based area. And for us, representing the Dutch government, we see a lot of opportunities, and it's very important that we now really have a concrete mechanism that will give us the opportunity to have bilateral projects between Dutch and Brazilian researchers and also private companies. So why is that important from a Dutch perspective? But I think the same holds also for the Brazilian perspective, is that we're all on the same path to make our industries, chemical industry primarily, more sustainable. So sustainability is a very important topic here, but of course also time and feasibility, because climate change is not waiting, climate change is happening, so we have to act. And with this program, we will hopefully also do a little bit of our part in doing that. So the impact indeed is that we, with this program, FAPESP and NWO, but also in a broader sense, I think the Netherlands and the state of São Paulo, are going to make an impact that not only helps the companies and researchers in both our countries / states, but that we also work on impact. So transition, biorefineries, and also the interdisciplinary part is very important, because we hope with this call that it will not be the last, let's say, project instrument that we construct between NWO and FAPESP, or maybe even other Brazilian funding agencies. About the budget, this is not directly my turf, but I'm going to say it anyway. So the total budget, and please, Connie, correct me if I'm wrong here, but the 3.8 million euros, that is the money that FAPESP and NWO are putting on the table. So that's, let's say, the public money. Well, here you can see the details about the two kinds of projects that we envision. Larger scale projects with an upper limit and a smaller scale project. But I think maybe the most innovative part, if I may say, Connie, in this call is that it will require a 30% private partner co-investment on the project level, right? So on the project level, and that is that's exciting. It's also, I think, quite new, and with that we also hope to really have the buy-in from the private sector. Timetable is is that correct?
Again? No, it's,
okay.
So it was okay on the.
Oh, now it's gone.
Yeah.
What did I do? I'm
it,
so sorry.
Yeah, it was when I checked it on the thing there. It was okay, but anyway. Can I just say then we hope to launch it then officially on the site in the middle of November, so in around about 2 weeks. And it'll stay open for approximately 2 to 3 months, and then all the usual evaluations, etc., will be done after that. So, but we just wanted to officially launch the call here because I think it was the best place to launch it. But please be aware that in the next 2 weeks or so that it'll be on our site, and it'll be on the NWO site as well. And so, but you know that it's coming. And so hopefully that we'll get loads and loads of proposals for financing. Although, as you say, and an important point is that if one of the lines of financing doesn't get a total number of projects necessary, the money will be transferred to the other line. It's not that there's going to be flexible financing in this, so that thing. So the total call, we did a rough calculation of around about 5.5 million euros was going to go towards this call. So thank you very much.
Thank you.
So, before they leave, the floor is open only for 2 questions regarding this specific call.
Just a clarification, the matching, the funds from the companies, the 30%, how can this be? Can it be in kind? Does it have to be in cash?
Normally, it's within the. It has to be according to the regulations of our PEACH program, of our innovation program that's called PEAT. So normally we ask for finance, not in kind. But it's something, it's one of the small points that we're still working out with NWO, because we have this regulation in FAPESP that it can't be in kind, but that's just one of the things. We're just waiting for the technical director to come back, and then we close that. Okay.
Keith Simons, Future of Biorefineries, the Netherlands. What is the TRL that you're looking to fund? Is it lab work? Is it pilot plant work?
We're looking for interdisciplinary work. I think, if I remember correctly, from when I read the call, it was somewhere around 3 to 5. So, but I'd have to check. I'll check it as soon as I get back to my phone, and I'll have a look at it, what it says. But I think it's 3 to 5.
Yeah, again, I'm not from NWO, but if I look at state aid regulations that we have in Europe, and we require 30% private sector co-funding, that means that it's not the lowest TRL level. So indeed, I think 2 to 5, I guess that is probably quite correct.
So, for matter of time, I think you have to wait for the release of the cow, and then I would like to thank you, Robert and Connie, to launch this call here and giving more value to our section. Thanks very much, Robert and Connie. So let's now start. Thanks very much, Robert. Thank you. Let's start our section now in the biorefinery, the future of biorefinery. I would like to invite the first speaker. Let's see who is in the program. João Nunes Carvalho from LNBR, please.
Thanks, Rubens, for the introduction. My presentation that I will do today is incorporating biochar into sugarcane biorefinery delivers ethanol and SAF with negative carbon emissions. As Rubens said, my name is João Carvalho, and I, together with my colleagues here, we prepared this material for this presentation. Como que é aqui? Esse aqui? Okay. Let's go. Let's start talk about global decarbonizations. According to IPCC, if you analyze here, just with the joint implementation of significant reductions in greenhouse gas emissions and the adoption of carbon dioxide removal technology, the decarbonization targets proposed by the IPCC will be achieved only with the joint implementation of both strategies. So if we observed several presentations that we can see here yesterday and today. Most of the presentations are talking about net zero or negative carbon emissions. But the question is how to do that. So we have the target, but how can we do that? And before these questions, the idea is each country, region, or a specific project has unique emissions profile. And consequently, different strategies should be implemented in order to represent those characteristics. If you analyze here, as Heitor mentioned yesterday, if you analyze here, the Brazil presents a different emission profile. The greenhouse gas emission profile is, if you compare just the emissions in Brazil with the emissions, the average emission in the world, we can see a large difference. Most of the emissions in Brazil are associated with deforestation and agriculture. If you analyze the world, most of the emissions are associated with energy production. So, in Brazil, much of the energy transitions is already underway. So, as I mentioned, here we can see here in the same graphic that Heitor mentioned yesterday, if you analyze here the participation of the renewable in energy metrics, in the world, around 15%. In Brazil, around 50%. It's a large difference. So, if you analyze just here in the Brazilian scenario, almost 90% of the electricity comes from renewable source. And practically 45% of the light vehicle fleet is fueled with ethanol. And as shown in some presentations here, ethanol is a good biofuels in terms of greenhouse gas emission mitigation. Sugarcane ethanol, I am talking here. Around 8% reduction in related to gasoline. So is a good number in terms of mitigation. But if you analyze here again the Brazilian profile, the country can be also one important protagonist in terms of CDR, carbon dioxide removal technology. So if we can see here some graphics that IPCC present in terms of carbon dioxide removal technology. There are some types of carbon dioxide removal technology. There are those associated with afforestation, soil carbon storage, or wetland restoration, biochar, BECCS, DACs, and enhanced weathering. So, but today here, our idea is to talk about biochar. How can biochar can help us to change the game? So, first of all, what is biochar? Biochar is a carbonaceous material produced by the pyrolysis of organic materials under high temperature and limit oxygen conditions. So, if you analyze here, biochar, excluding the well-established nature-based solution here is afforestation, soil carbon sequestration, or wetland restoration, biochar presents the highest technological material in terms of technologies to remove CO2 from the atmosphere. And so we can talk about why biochar in Brazil. There are some studies indicating that Brazil, together with United States and China, are the biggest countries in terms of potential to use biochar to decarbonize the economies. So, but why biochar here? Especially Brazil is a big country, and with favorable conditions to produce biomass, Brazil presents a well-established agro-industry with a large amount of residual biomass available. And also, biochar can be one good solution for Brazil and other tropical countries, especially because most of the Brazilian soils present a low carbon stocks, and especially because it's difficult to maintain carbon in tropical soils. The same climate condition that is good to produce bioenergy is good to decompose organic material. So, more stable carbon inputs like biochar could be one good solution for Brazilian soils. So, and there are some other co-benefits in terms of biochar. We can see here some benefits in terms of improved soil quality, increase crop production, and increase the resilience to climate change extreme events. So, based on that, we have some ideas that the inclusion of biochar in the sugar energy sector should be an excellent idea, but little is known, little information is available on the effects of the biochar on sugar energy sector. So, in this study here, we conduct a life cycle assessment to estimate the carbon footprint of sugarcane ethanol and derived SAF, include the GHG emissions associated with energy transition by the production of biofuels, and associated with the carbon sequestration with the use of the biochar. So we know that the ethanol and SAF will be good biofuels to substitute the fossil fuels. But what is the impact of the inclusion of carbon dioxide removal in this sector? So, in this study here, we consider autonomous ethanol industry, and we use the recovery of 50% of the straw from the field. The lignocellulose material in this study was used to produce heat, electricity, or destined by pyrolysis. All emissions from the production of sugarcane, ethanol, SAF, and the emissions associated also with the pyrolysis was included in this analysis, and the SAF was produced by the alcohol-to-jet route. Let's start talk about some results. So just to give one overview here associated with the pyrolysis, we consider here a pyrolysis, a fast pyrolysis, with when you use the bagasse and the straw as a raw material. And here I am present some informations about the yield, the pyrolysis yield associated with the syngas that was used for heat, the bio-oil, and the biochar. So the biochar application was simulated in each 5 years during the sugarcane replant period, and the carbon sequestration was estimated using the IPCC recommendations. So the scenarios that we evaluated here, first of all, we have the most common scenario here in sugarcane sector. In one scenario that we use the cane to produce ethanol, and also part of the residue was used to produce electricity. It's the most common system in Brazilian sugarcane market. So the second scenario that we evaluated here was the same, but here we include the pyrolysis and the return of the biochar in sugarcane fields. Here we have the numbers that was producing in each scenario, but the idea here is not to enter in details with these numbers. But we have also one scenario associated with SAF. The first one is the similar than the scenario one, but the ethanol was used to produce SAF. So the products was SAF, green gasoline, and green diesel, and electricity. And the last one is the same that the scenario 3, but here we include also the pyrolysis and the production of biochar and bio-oil also. In both scenarios that we include the pyrolysis, practically half of the lignocellulose material, bagasse and straw, was used for in the boiler, and half was used in the pyrolysis. In the first, if you analyze here just the scenario 1, we can see the ethanol carbon footprint around 17 grams of CO2 equivalent per megajoule. as most of the emission was associated with biomass production. It's normal in practically all studies associated with sugarcane. But when we include the biochar, the game changed a little bit. Not so. If we analyze here, if I return here, if you analyze the graphic, just the emissions, if you analyze just the emissions, it's practically the same, a little bit higher, it's because there are some emissions associated with the pyrolysis, but we can see the carbon sequestration resulting in ethanol with negative carbon emissions. And if we analyze the use of ethanol to produce SAF, the results are very similar in terms of the presented for ethanol. But the magnitude changed a little bit, but the carbon footprint of the SAF was 21, and if you analyze just here with the carbon sequestration is minus 2 grams of CO2 per megajoule of SAF produced. So, just to give you one overview of the results, if we consider here the scenario 1, the scenario 1 is that one, we can observe a reduction of 81% of the greenhouse gas emissions, just producing ethanol. If we use ethanol with biochar, we have negative carbon emissions, a reduction of 102%. And if you analyze the carbon footprint of the jet fuel, and we compare with the SAF associated with ethanol, we can see a reduction of 76%. And when we consider the SAF and biochar, 103% of reduction. So, in summary, we can conclude that the production of ethanol and SAF is a feasible strategy to mitigate the greenhouse gas emissions through the energy transition. The inclusion of a pyrolysis plant into a sugarcane ethanol biorefinery can deliver ethanol and SAF with negative carbon emissions. So it's important to mention here that we include in this study just the carbon sequestration associated with the biochar. The co-benefits of the biochar, it's not included in this study. We intend to do it in next studies, but we have some information indicate that the application of the biochar in the field reduce a lot the emissions of nitrous oxide. So, and we know that nitrous oxide represents around 50% of the ethanol carbon footprint. So, if biochar reduce N2O emissions, probably the emissions of the nitrous oxide emission will be reduced, and also the carbon footprint will be reduced. So, but we need to analyze better this result, especially because we applied fertilizer every year, and the application of the biochar will be in different periods. So we need to analyze if the effect will be consistent along the 5 years, for example. So Rubens, thanks for the opportunity. I am finished here.
Thanks very much, João. Very nice talk. Thank you. I would like to invite Professor Kees for his talk, please.
Okay, thank you very much for your kind introduction. Thank you very much for inviting me to present here the Integrated Biorefineries mission. So my name is Kees Kwan. I'm from the Netherlands, from the Ministry of Climate and Green Growth, and from the agency. And I'm the mission director of this mission, so I'm very glad that I can present to you what we are doing and also, let's say, what we try to achieve with this mission. And you all can be part of this. This mission, innovation, actually was launched in 2015 when all the ministers met in Paris. They agreed on the Paris Agreement, but they also said we also need innovation to be part of this. Because without innovation, we cannot reach our goals. So it was launched then. 23 countries are participating in this, and it's all about improving our, let's say, the output of our innovation. It's action-oriented to support research and development, and it's really about global coalitions between government and private partners. So 7 missions were formulated. It's about hydrogen, it's about green power, but also about urban transitions and industry. And here we are talking about the Integrated Biorefineries mission. The Integrated Biorefineries mission really has the goal to find innovative solutions, to enhance commercialization, so to shorten this trajectory, but also to reduce the cost of biorefineries. Because costs are really a problem, and so we have to solve that so that we can accelerate the deployment of different applications of biorefineries. And finally, it's also to support international collaboration between the countries that are participating in this mission. We have at this moment 7 participants. So actually this mission, it is led by India and the Netherlands. So we are responsible for this mission on behalf of the ministers. We have core members from Brazil and Canada. So Brazil is a very important partner for us, so I'm very glad to be here in Brazil to present this mission. We are also supported by the United Kingdom and the European Commission, and I will tell a little bit more about that later. And recently, Switzerland also joined our mission. So we are open for new countries. So when you are from another country and you feel your country should participate, you're welcome. So we developed first a roadmap to see what needs to happen in order to achieve our goal. And there are 3 pillars. First of all, research and development. It's about new products that we can produce from the biomass, but it's also about improved efficiencies of existing biorefineries and how to reduce costs. The second pillar, it's about showcasing that it is possible. So it's about pilots, it's about demos. And from demos we can learn, but also improve. So it's a process that you are in when you are doing innovation. And finally, this all does not make sense when we don't have the right market conditions. So we need an enabling environment for biofuels and also for bio-based chemicals. And actually for biofuels, it exists to a large extent, but for bio-based chemicals, we still have to work on this. We do this all in close collaboration with other organizations internationally, for example, the other missions that we have. I mentioned them already before, but also the SEM BioFuture initiative and campaign, the IEA Bioenergy Technology Collaboration Program, the IEA Arena, and so on. So talking about these pillars, we have developed 8 actions. So first of all, it's about working with industry. So we organize workshops with industry, mostly webinars, to discuss what needs to be done. We also work closely with the SEM BioFuture campaign, where industries are involved, and with that we obtain information on what we should do. So action 2 was about new products. So what we have done is we've organized a webinar with industry to see what needs to be done. And actually there are a lot of different products that you can produce with the biomass. And actually the most, let's say, prioritized were the biopolymers and also surfactants. So the biopolymers were taken up, And we have now set up a group with collaboration with, let's say, different organizations in our countries. And it's about, let's say, people who have a specific focus in this area. So, for example, in the Netherlands, it is the Bio-Based Circular Consortium. And in Europe, we have the joint undertaking of the Circular Bio-Based Europe. We have in Canada and within NRCan a special association. Switzerland, we have Bloom, and also the UK research have also a special organization working on that topic. So we are now see how we can improve the collaboration specifically on the biomass availability for, let's say, the biopolymers, the end-of-life management, so how do we consider it to be reused, or do we store the carbon in these biopolymers? Of course, cost competitiveness, and what can we learn from each other to improve that, and scale up. It's very often, it's a new element, and it has to be scaled up. So in order to realize efficiency improvement and also bring down the costs, we had organized a webinar also on that, where we have seen that process integration is crucial. So that's why we are also called integrated biorefineries. We also should increase the output, the value of the output, so also specifically looking into the byproducts, and but also see how we can improve the diversity and also control the supply chain, because supply chains often are crucial to realize biorefineries. We are also supported in this work by a Horizon Europe call. It was already mentioned yesterday by Maria Georgiadou. And so this is really a call that supports innovation to bring down costs and so on. So, and finally, in this area, we are also looking at SAF assessment. So the SAF assessment is quite crucial, because what we see is a lot of biorefineries are now being built and being developed for the production of sustainable aviation fuels. So Brazil and Canada are working together to see how we can realize, let's say, what could be the opportunities for sustainable aviation fuels. And so what we need is an assessment tool to look at these different value chains. And at this moment, we are now at a stage where we have evaluated the value chains that can, through Fischer-Tropsch, let's say synthetic fuels and SAF. And basically for Brazil, we are looking at sugarcane, so the bagasse, and for Canada, the forest residues. And then it's the gasification and the syngas utilization. And then on the output side, we try to compare them, let's say, looking at, of course, the economics, the selling price, but also carbon intensity and the greenhouse gas abatement costs. So these are different criteria to compare them. And if you want to know more on this specific study, tomorrow at 2 o'clock in this session, in a session called PS20, it's from bioproducts and biorefineries. More details about this study will be given. So on Pillar 2, pilots and demo, we are looking at creating an inventory of experiences, but also on how to make a business plan. And actually, by interviewing financiers of pilots and demos, we have developed a guide that is available on our website to help people to develop these biorefineries and these let's say, pilots and demos. Crucial elements are, of course, reduce uncertainties. That's what financiers don't like. So it's all about feedstock, the technology, and the markets where risks need to be reduced. And standards also help to develop market and also the demonstration projects. So we have already a lot of ongoing work. So 2 participants in our mission, UK and Canada, are looking into this. Finally, about markets and policies. This is not something we do alone, but we do closely in collaboration with the Send by Future initiative. It was already presented this morning by Kees, the report from Oak Ridge National Laboratory on the biomass availability. So we follow that work, and we see that also for the availability of work that is available for the resources that are available for our biorefineries. We also collaborate with the UNEP LCA project initiative to see how for biogenic carbon we can come to a general approach, not only for biofuels, but also for bio-based chemicals. And that is quite crucial because there are not yet standards available for that. So it's a process that we try to help also. And we also discussed at the SEM-MI recently in Vos di Gazou about bio-based chemicals for green growth, because we think that's an underestimated, let's say, area where we, from our mission, we try to stimulate that. So this was, let's say, already somehow presented before. So the results from the G20 SEM15 MI9 3 weeks ago in Vos di Gazou, where we also participate. And actually what has been achieved is that what we see is that there is really a request for from the G20 to increase consistency across the methodologies for assessing greenhouse gas emissions. So that's work we have to work on, and we will do that in close collaboration with others. But also there is this SEM action plan to accelerate future fuels. And I think that's important, and our mission with developing the biorefineries can support that action plan as well. And finally, we have organized a special session on biomanufacturing and bio-based chemicals. And in that session, we have seen that what we need to do is stimulate more the biogenic carbon in chemicals. So our ministry is working on the topic. It will bring forward proposals on that topic to the European Commission, but also at the COP29 and next year in COP30. And tomorrow, in a special session with the Dutch-Brazil Roundtable, you can hear more about it. So further, we are looking in, let's say, innovation missions to see bilaterally how we can combine, let's say, our efforts, so to bring our industries from different countries together. We co-host events with the SEM-MI, so we did that already in India and in Brazil. But we also support joint funding, so I was very happy to hear that today we could launch the NWO and the FAPESP call about biorefineries, because it's bilateral, but we're also looking into, let's say, multilateral approaches, for example, through the CETP, which is a European collaboration, but we try to open it also for other countries. And finally, we launched a biorefinery platform to facilitate networking and building projects between industries and researchers. And I will tell you a little bit more about that, because this digital platform can also help you. It helps networking between all the people that are here in this room. We will organize webinars through this mission on specific topics that might be of interest, so that you can know from each other and find joint efforts to develop projects together. And till now, actually, we are with 100 participants, so it's a growing community, and you're also welcome to join this community. So, to conclude, my key takeaways, so it's a network across, let's say, it's a global network, so it's not a European network, it's a global network where you can all participate. It implements a comprehensive roadmap for biorefinery innovation, biorefineries for fuels and for chemicals. We always look at this combination, and this platform will leverage our international expertise, and so that we can share lessons, but also develop new approaches. So it gives us and you an access to a broad range of expertise to develop joint R&D projects. And as I mentioned before, we are open to additional member countries. So thank you very much for your attention.
Thanks very much, Professor King. I invite Professor Paul Stuart to listen to his talk. Please.
Thank you very much, Rubens. And just to say, I'm thrilled to be here again at BABEST, Best in Class conference, a very special one, at the intersection of biofuels and policy, and so appropriate that it's here in Brazil. So this presentation is about a study we did for Natural Resources Canada, looking at the impact of innovative policy on the bioeconomy broadly. And it was done by my company Invertis in collaboration with 4 other dear boutique consulting companies from Canada with different specializations. There we go. So my company uses, we've developed tools and methods to make fact-based decision making. So we lie somewhere in between a management consultant and an engineering consultant, and we work primarily for the forest products industry, but also allied industries, government, and technology developers. So this project, the premise of the project was, we're here today, we're headed towards Paris in 2030, and there's this thing coming down the pathway a bit further at net zero in 2050. So the question is, what kinds of innovative policies should we put in place that won't take away value from the policies in place and will help accelerate the path towards net zero? And at the same time as reaching net zero, the goal was to make a competitive bioeconomy. So from the terms of reference, the goal of this was to inform the path forward to Canadian governments, and that would be federal government that sponsored the work and provincial government to achieve economic environmental policy goals going forward. And so, of course, we called it focus areas, but they're technology platforms which put together form a value chain and through to the product quality. And then there's the market side of it, which is, of course, very independent and often is the problem if you're talking not biofuels, but lignin-based products or hemicellulose-based products where you're selling a functionality. And then there's the different innovative policies that superimpose on those different strategies. So the methodology we proposed to address this was a case study-based approach, so very much a bottom-up approach where we defined, as you'll see, sites, technologies, and their economics. And in this presentation, I won't talk very much about the first 2 because the idea is to focus on the policy aspect of this study. So the objective of the presentation is to make a summary of this called the Fiber Futures Project, de-emphasizing the aspects of technology and techno-economics and emphasizing the impact of policy. And that's a disclaimer that I have to put up every time that says that the government's not responsible for any of the misinformation I'm going to give you today. So I'll tell you about the project methodology, how we defined or simulated what the Canadian bioeconomy might look like, and then jump into a few, anyways, of the policy scenarios and results. Okay, so we started off with something called a foundational analysis where we picked out 3 very important areas. One of them was technologies, of course, and that was for a 2-week period at the beginning of the project, and we continued doing it all the way through to the end of the project. There's so much good information, insights, and opinions on the bioeconomy and what it could or should be. And then we went through that middle block, which was a triage. I'll elaborate on that a little bit more in the next slide. And we had to show what the impact of policy would be, and we invented something that I'll tell you more about, also called the attractiveness grid. And then we saw how the attractiveness grid changed under different policy scenarios. So, of course, key indicators are important for this sort of thing. We established 5 that were economically related, and we established 5 that were related to policy goals, so societal impact and environmental impact. And at the first triage, we had over 100 value chains or that we were looking at the beginning. We triaged down to 18 and then finally down to 11. And we did that using showstopper values of some of those 10 KIs, key indicators. And then we used all 10 key indicators in this so-called attractiveness grid. So you can see the showstoppers for the first triage and then the very systematic evaluation of the 11 remaining technology platforms. Let me tell you a little bit more about that attractiveness grid. So on the top left there, you see a grid of about some reds and some yellows and greens. So green means that the KI had a strong value for that technology platform. The red was above the minimum thresholds for those showstoppers, but still not so good. And yellow was somewhere in between. And when we apply the different innovative policy scenarios, you can see it's going from red, yellow, and green to more yellow and green in the other three examples, just to show you the idea, the concept behind that. So now we define we've got the short list, and now we're going to define our Canadian bioeconomy. So there were 5 bioenergy value chains. It's actually 3. The 3 in the middle were different variants of fast pyrolysis. We had cross-laminated timber, which is a very profitable, limited market opportunity that Canada knows and loves. The 2 V7 and V8 were fractionation value chains, so if you will, breaking up the cellulose, hemicellulose, and lignin in the biomass feedstock. And you can see that third column there is inspirational examples. So the nature of the value chains and assembling them were really related to projects that are advancing towards commercialization or at commercialization. And the last 3 there are integrated into existing pulp mills, lignin extraction, which we're all probably familiar with, green hydrogen generation from co-generated electricity, and the last one is something called the bioproducts mill, where we optimize byproducts from a pulp mill and make added value out of those. So we have those 11 value chains. We started with 18 locations in Canada, reduced them to 9, and then we defined 37 case studies where we combined the value chains and the locations. And then we put value chains together. So we used up nearly all of the available biomass in the different regions that we were looking at. And the regional bioeconomy was of course, used for the social impact metrics. If we did have a successful bioeconomy and it used up most of the biomass, then how much would it influence the GDP of the area, and how much would it influence the employment in the area, divided by the resident one. And so in those 9 locations, 4 of them were one-offs, and 5 of them we moved across the different strategies with different parameters as a background, how much and what quality of biomass, what it cost to get to the mill gate. Then on the other side, the product transportation cost, which was surprisingly important. On the west coast of Canada, we go to Southeast Asia, of course. We go to the mid-US in the center of Canada, and we go to the largest chemical market in the world, the US Northeast from Eastern Canada. Electricity costs and the grids change across Canada, and the policy background, which is largely the same with some subtle differences, in particular British Columbia, which has a low carbon fuel standard. And we made these regional bioeconomies. So here's an example of, 80% of the effort, but not really focused on. Here's the simplest one, torrefaction to black pellets. You can see red, which is phase 1 before 2030, blue, which is carbon capture after 2030. It's inspired by a Portuguese implementation. We worked through all the balances, did all the economic numbers, and then we used that for different cases across Canada. Let's get to the results. So to calibrate more than anything, we said there was no carbon pricing, $50, which is where we kind of started the current ramp up. We're ramping up in Canada, $15 a ton until 2030, when it's $170 a ton. Those are Canadian dollars. And then we made an innovative policy. One of the innovative policies was to continue that pathway to $340 a ton. It sounds like a lot, but I'm preaching to the converted here. Most of the people we talked to thought that was entirely a reasonable thing to do. So here's first result, if you will. So this is under business as usual policy, which means 2030 and $170 a ton. And you can see along the bottom the 37 case studies, and they're grouped by the different value chains going from torrefaction through to those last ones integrated. And so you can see the VCs along the bottom of that. And 20% internal rate of return is, if you will, the number you need to get into the pot to be considered by a forestry company. And really with risk, you're looking more towards 30% as a target value. And so you can see there's a number of strategies there that are in an attractive range, and it won't be a surprise. Value chain 9 is lignin extraction to products. Value chain 7 is fractionation to lignin and textiles, was the context. And value chain 6 is cross-laminated timber. And so those are really good ones. And I highlight the fast pyrolysis technologies because they're not attractive at a low value. They are highly impacted by, of course, the carbon value. And so it says that today they're not very attractive to implement in Canada. In 2030, they'll start to get very interesting. Then we defined, now we get into the policies. And we worked with a group called Navius Research in Canada, who are the go-to people for policy in the area of biofuels and the bioeconomy. So we had the business as usual of what's in place today or nearly in place today in Canada. We had enabling policies that don't cost, that cost nothing or nearly nothing to do, but if you don't do them, we won't succeed. And then we had these ones, the most important ones, innovative policies. These are policies now not in place. We looked at fiscal policies, forest land use policies, and carbon policies. And then we went on to what we call targeted policies. So very focused green procurement or other similar policies. And extreme policy scenarios are the dream where we actually combine some of those things to see how good it could get. So the devil's in the details. What did we assume? So to fiscal, I'll show the main ones that we emphasized. Accelerated depreciation, so 1 year can happen for certain categories of a capital asset in Canada. We cut the tax rate by 50% to see what that would do. Then we subsidize residues. Residues are something we don't collect in Canada. They cost a lot of money and they cause forest fires, or they exacerbate the potential for forest fires, so we put a subsidy on that. And then we looked, most land in Canada that's used for the forest sector is government owned. And we looked at experimentation with privatization. It's not very Canadian to do that. And then we made assumptions on how efficient we would get if we did that. Then the idea of carbon sequestration for long-lived carbon products. And then that thing of going from $170 to $340 a ton for the carbon value. And then for the targeted policies, we really just focused on 3 strategies. One was black pellets, also biofuels. So we increased those residues subsidies. Biofuels, then we looked at that more closely. We increased the capital costs support for the capital, the large capital needed for a world-class plant. And then we took that low carbon fuel standard in BC, and then we superimposed it in other parts of Canada. And then the last one, which was actually the most interesting one, which I don't have time for, is to put in place lignin and roads mandate and use that as a catalyst for a lignin-based bioeconomy. So how did this work? Here we have just one of those criteria, the 10 criteria. It's early technology implementer advantage, which means you get first to market, and the disadvantage of the experience curve where the costs come down over implementations. And you see 2 purple lines there, and the 37 case studies rank from low, 0 or negative, to high, much better than those, and then a whole bunch in between. And we ranked them from low to high, and we had 50 percentile less in the red light zone and 25 percentile in yellow and green for business as usual. And then as we superimposed the innovative policies, then we multiplied the criteria times the internal rate of return. So as the policy was monetized, these normalized values would go up from red to yellow to green. So here's Along the top, you've got the 10 key indicators, and they're shown here on the right. And you've got the 37 case studies there. So half of those are red, a quarter of them are yellow, and a quarter of them are green. And then you've got some metrics there, and along the bottom, just to do some success measurements. So the first column along the top right there is how many green lights there are in a row. So if you're a company, you just want to win, you really need a lot of green lights there in order to make an investment decision. In the second column, we gave 3 points for green and 2 for yellow and 1 for a red, and then we added them all up. And so that's how the overall bioeconomy would be impacted by a given innovative policy. And then we Z-scored in that last column, so half of them are red and half of them are green, and we saw how that changed with different innovative policies. And those numbers you're going to commit to memory, 88 and 644, that's how many green lights and how many points in those first 2 columns. And I don't have time here, but that's one of the juicy options, cross-laminated timber. And so you look across and you see, well, there are red lights on that right-hand side, which are the social and environmental indicators. And this is the other juicy one. And there's a lot of yellow lights for the financial side. So it isn't quite as good as cross-laminated timber. So we could look one strategy at a time. So if we take a look at how that was considered, so policy 4, which has changed the harvesting technique, the only thing that matters here are those 2 numbers, and I know you memorized those last ones, but just in case you didn't, they're here. The business as usual had 88 green lights and 643 points, and what we just looked at was the experiment with 10-year modernizations that went from 88 to 98, and 643 to 685. And so we could look now at the impact of the different innovations on this simulated bioeconomy. So accelerated capital depreciation, because we're making a decision today for 2030, didn't have a big impact because of the time value of money. And if you don't make a profit, then you don't get your depreciation value. So it had the least impact. We like accelerated capital depreciation, but it wasn't so important for decision making. The reduction in corporate tax did have an impact, but the impact was not as large as I thought. Subsidized residues collection and experiment with 10-year modernization. The beauty of these 2 together is that if we subsidized residues, that would be active today, and you would encourage people to go and use forest residues today, and you would encourage them to make black pellets out of that, because whitewood would cost more money. And then if you also promulgated 10-year modernization, that will take 10, 15 years before it has any impact. So they're, if you will, they're married together nicely. Increased carbon sequestration by substituting bioproducts, that's, if you will, the average value, but it had a great value on lignin-based products, for example, and things with long-lived products, and not so much if we burned the bioproduct. And double the carbon pricing, not surprisingly, is a winner. So take-home messages from this. It was a very practical approach, a case study-based approach, looking at the 2030 and 2050 contexts. We looked at those 3 broad types of policies, which have, the law of unintended consequences, and targeted policies actually were the most interesting of the ones we identified, I think, anyways. And we could look at their impact on any number of scenarios if you want, and then we went to extreme policy scenarios to look at those as well. So I did this slide on the plane on the way here. And so it's a SWOT analysis in 60 seconds, and it shows Canada and Brazil. And if you will, the parameter in the first column is that which is important for the bioeconomy advancement, and diametrically opposed. And so the beautiful thing about this is, well, you don't expect the same bioeconomy in Canada as you do in Brazil, and that is very clear. But from this, we have an advocacy strategy. So every country can do this similar approach. Every company with many facilities can take the same approach and can orient their advocacy or knowledge building with government and industry to be able to identify, in fact, what scenarios would be best for their case. That's it. Thank you very much.
Thanks very much, Paul. So I invite now Fabian, please.
Hello. That's working. Exactly. Thank you for still being here. I know it's late, but let's go through this Biorefineries presentation. We started this project 6 years ago within the IEA Bioenergy, and we did basically the results for the IEA Bioenergy. But before I started this project in 2018, my life changed completely. I got married, and the only numbers I want to remember is 95% of the reasons I got married was because it was pure love, and the other 5% I will not disclose here, but it was definitely not for money. Like, neither her nor me, we were not marrying for money. But 6 years down the road now, I must confess, I see that the efficiency of our spendings, like together, is actually much better. Like as a couple, you spend less for a person, right? So you have a community and you spend less on food and fuel and whatsoever. But the second very important factor is also that we have each other's back. So in the end, if one of us goes into carence or any timeout, the other one can actually chip in and finance the other, right? So the second really important part here I want to remember is that we are actually financially more resilient now. It's about reliability, resilience, and having a stronger finance together. These are two very distinct factors which we did not consider when we married, but I think that's something we can consider when we are marrying different sectors like material, food, energy sectors in the biorefinery. And that's what this presentation is about, and no more numbers. So the pre-study, the first study we did, we published in this beautiful journal article, which I recommend everybody to read, of course, where we figured out that there is actually something about the biorefinery or bioeconomy, that was the topic back then, the bioeconomy in general, which is quite interesting. It connects these different networks with each other. It connects storages, networks for fresh biomass, for energy commodities. It connects, it marries, so to say, the hydrogen grid together with the CO2 grid, and so on. So we asked ourselves the question, what is exactly the added value of this marriage, of this integration? What's the added value of system integration here in general? We also have this journal article collection here, and any scientist in the room, if you consider publishing, we still have 2 spots in this collection. And if you write that you're coming from the conference here right now, got inspired, of course, you have it quite easy. So what we did for system integration, we got a bit technical and thought about, okay, what's now really the added value of system integration? It was a word dropped today by Kees already, others, like it's about, there is something in this biorefinery integration concept. We have to think about integration itself, first of all. And here is an easy definition, in my opinion. The process of combining at least 2 elements to form a whole. And what you do in ISO standards, when you define something, you have these notes which go deeper into detail. Note 1, the elements can be resources, infrastructure, technological components, and processes and whatsoever. And they can be intangible, like something you cannot grab by your hand, right? They can be intangible, also like social structures and relations and so on. And very important, note 3, the whole is more than the sum of its parts. The synergies are, on the first hand, the ability to exchange resources or to improve the resource flow efficiency. So that's where we have lower spendings, right? And second, equally important is that the synergies, co-benefits, or however you want to call them, is also this improved resilience of the individual elements within this community, or within this integrated system. Then the last Right. The last 3 years I spent at TU Wien at a very process engineering focused department, and me myself being a systems engineer, we had to follow up with the question if this is actually something we can translate into processes defining. And here we found different concepts, which are listed down here, which are all having something to do with this system integration aspects, even though they have different wordings, different disciplinary jargons, different types of language used for describing this integration aspects. And even energy communities are, in my opinion, some system integration concept, but also sector coupling, which is very strong right now in the whole electricity sector, where it's all about flexibilization through system integration, but also process intensification in industrial operations. And all of these, I would say, are interesting for system integration and thinking about this definition here. This I will jump. Okay, now let's go a bit more in detail with these two elements of added value for system integration. The first 50% value of system integration, as I said, is all about efficiency. You become more efficient. But if you only consider the energy value or the energy flow of your biorefinery, you might not see the full picture and don't see how much more efficient you actually got. What you have to do is you extend your resource scope. You have to think about all the different tangible and intangible resources, look at all their flows, see how the structures of your material are kind of kept safe, and you can still do something with the structure of the fibers, for example, the lignin, but then there's also a collection of other resources listed here. And we went through different case studies in this collaboration to work this actually out and so, okay, that's a good approach that extend our scope of different types of resources to see this efficiency for different resource flows. But then, again, the second side of this coin, the second 50% value of the system integration is this whole probabilistic effect of resilience and reliability. And it was really tough to get our heads around it and to figure out how we can actually quantify and approach and simulate and model that. But first of all, we had to figure out what do we make our systems more robust against. And here is a little collection of different types of uncertainties. You can think about uncertainties coming from the atmosphere, from temperature fluctuations, but also in the biosphere. If we talked about today about forest fires, for example, you also have uncertainties in the geosphere with earthquakes and whatsoever. In the textosphere, more and more, it's about safety and security. Again, different types of word, but it's a similar concept. Sociosphere, of course, and very little is done on the cybersphere, so we, of course, have uncertainties in connecting, in having more digitalized supply chains, for example. There's different uncertainty types. I now said a lot about extreme events, but there's also uncertainty in the trends and the variabilities and cascading effects. Super interesting scientifically. Please, I can talk to me for the next hours. There's a lot to talk about here. But for the sake of the time, we then went into defining another word. We defined flexibility. Like this flexibility coming out of a more integrated system is actually something we're looking for right now, especially in the IEA Bioenergy Task 44 in the next triennium. That's part of the IEA Bioenergy, where we look exactly into this part. And here we say you can actually flexibilize your system. You can be flexible by shifting resources. Like remember my wife's and my budget, where we shift resources with each other. You can shift these resources through time, through space, between domains, and between options. And this is the full picture of flexibility. I'm not going into the situation that this is actually a neutral definition, that it can have beneficial but also detrimental consequences. But you can expect much more from the IEA Bioenergy Task 44 and that next triennium, next 3 years of work. And now, to lighten up the room a bit more, can we find a common framework which is like simple and quick to address, which combines all of these two different elements of system integration? And for that, what we looked now, actually not first, actually quite late, we looked into into the most integrated system we know. And the most integrated system we know is the biosphere, is ecology, is ecosystems. And here the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, they looked for a long time on ecosystem services, as you see in their names, but now they're shifting the focus to nature's contribution to people. And here they talk about these elements which are addressed in the last slides, actually. We talk about the material contributions, which is for energy, food, feed, and so on, and whatsoever. The non-material contributions, which is about the socio-economic, social impacts, and especially the last point, the regulating impacts of these ecosystems. They can regulate your system, can moderate when you have certain hazards coming up. If you have flood control, this is the most important right now. You actually regulate against flooding and also dry events. This flood control is most likely better if it's bio-based. And now the question is, can we biomimic this concept to our biorefinery discussion here? And we believe we can. So we have these material contributions for bioenergy being used for food, materials, and other provisioning systems. The biorefinery providing also fertilizers and medicine and whatsoever, but especially also, second point, non-material contributions, the socioeconomic benefits. Maintenance of option means that you can actually reuse old infrastructure, which is already there. And then especially, again, the last point here, the balancing. We don't say regulating because that's kind of the word's already taken, but like this balancing part of biorefinery for technological recycling, wastewater treatment, carbon sequestration, and especially this flexible operation and storage of any type of resource. And the last two slides I would ask for other IEA Bioenergy colleagues to look up, because this is already the work program for the next 3 years of all the other tasks, and we see in their work packages description a lot of good links to talk about system integration and bring it together in a joint findings. So just for a second, if I have to take home messages here, measure, when you look in your biorefinery, measure the degree of integration. Think about how well is your system actually integrated? How much more is it integrated than other systems, which are maybe much more simple, less complex, and maybe even much more interesting for the regular policymaker or anybody who is not too proud for complexity. So be proud of your complexity, think about its integration aspects, think about how integrated your system actually is, think about how you can measure it, include a broader set of resource efficiency indicators, not only energy, but also all different types of energy, of resources, tangible and intangible, and please include indicators and try to understand how it actually creates this resilience and robustness and reliability of your individual systems. And we can also clearly see that if you do comparisons, which are quite often used in science, if you do techno-economic comparisons between photovoltaic and synthetic and other specialized processes with this complex biorefinery and bioeconomy processes, you most likely will fall short with your biorefinery or bioeconomy if you do not consider these 3 points here above. And that's what is most often done nowadays. The circular bioeconomy and biorefineries should be designed to amplify nature's beneficial contributions, so we can actually tap into this already existing biodiversity framework. Now, being on this conference here in Brazil makes it quite clear to me that it's not something which is new to many of you, maybe. So we heard today about the indigenous bioeconomy. That's exactly what they're doing, I guess. We can learn a lot from here, being more organic, being more nature focused. Look out for commonalities. Yeah. To my IEA colleagues from the other tasks, let's look out for commonalities and see what we can do together based on this system integration discussion. Thank you so much.
Thanks very much, Fabian. So for matter of time, I will just open the questions to the floor. See that you have different views here. We start, just to remember, some strategy to carbon capture and use on land to improve the productivity and the very good impact on the SAF. Professor Kees mentioned just what João Carvalho told us. Professor Kees comment about his project, his platform, to help us in the research and development, pilot and demo, and the marketing policies. Especially, I found it quite interesting to learn lessons learned for the past and how we can use the past experiences. Paul Stuart make a very good lecture about multi-criteria decisions, plenty of colors, but he resumed in 3 colors then. Yellow, green, and the red. That's why we think about that. And now Fabian talked a lot about the many things, but the efficiency and how can we integrate several criteria, several index to take decisions. So it's open to the floor to learn more about this very enthusiastic topic that is the future of biorefinery. If you don't have a question, I will ask you, Paul, in your vision, what is the future of biorefinery?
So I work closely with industry, and I like to say who's going to invest at the end of the day in the biorefinery. It's going to be industry, and so industry pays the money and they take the risk, and so they're getting very good at doing that. And if you will, you have your platforms of biorefinery, and then you have your best-in-class technologies, and then there's that other thing down here when you look at those different combinations and first transformation and second transformation going to added values and drop-in fuels. You have that thing called competitive advantage. So how do you use your locations, your manufacturing platforms to your ability? And so the answer to what does the future look like for the bioeconomy or the Canadian forest bioeconomy in this case is really going to be company by company. And it's going to be to maximize their competitive advantage so that they're in business for the longer term. So there's no one answer.
Okay.
Yeah.
Somebody wants to complement his view? Professor Kees, want to?
Yes. I think indeed it is a very versatile future. Yes, there is a big range of different biorefineries, and I think this was also shown by Fabian. So how can we integrate? And so in the future, I really see the future for, let's say, integrated biorefineries that can produce fuels and biochemicals. And because whenever you take one product out of a biorefinery, there are always residues. Yeah, so how to valorize these residues adds value to the overall process. So I think this approach of optimizing the value of all the outputs, that will be crucial. And then in course of time, I see, let's say, a shift from, let's say, biorefineries producing fuels to biorefineries producing bio-based chemicals. Yes, that will become more important in the future, the more, let's say, alternatives we get for the fuels. But it will take time, but we will see there shift as well.
Very good, thank you. João, you want to complement, and later on Fabian, can you always already thinking?
I think that the idea is the same. We need to produce more, recycle more, use better especially the residues that is, or the co-products in some places. In most of we can see in several biorefineries, the co-products in terms of volume, is higher than the main product. So if we improve the use of these co-products, maybe we can change the game. Yeah.
Thank you. Fabian?
Yeah, so we asked ourselves this question also the last years, and what we see is there will be alternatives in the future which are absolutely not bio-based. You can produce everything out of thin air in the future. You can produce even food out of carbon captured with renewable electricity, and that's actually what some colleagues are already doing. You can produce materials, you can produce everything without touching nature at all. So now the question is, if you talk with policymakers and especially also with investors, like why should you go for the more complex pathway where you have to involve many more people and you have all this upstream and downstream and then all the risks in this little paths. So that's now the question we try to answer here too. And in the end, exactly this complexity of what we said here is the solution, or is actually the one convincing argument if you bring it on the table correctly, where you can say, well, if you have more people involved, first of all, like all the people, all the supply chain persons on the ground, just think about how well you can automatize these processes. Not at all. So you have actually steady, good working jobs for the next 20, 30, 40 years because you cannot automatize a pruning process and whatsoever and all the upstream things here. Then you have all the people making decisions and having objectives on their own, and this is exactly what makes the system stable. It's not about acceptance. Please don't talk about social acceptance of your processes. It's about social participation, and that's what you get the key. Something the non-bio-based, the synthetic processes, they can totally not do. I mean, you can combine non-synthetic or synthetic processes with your bio-based processes, of course, this is great. But if you have a purely synthetic process supply chain lined up, like you can automatize this wonderfully, you don't have any people involved, but it's also not as resilient and stable because there's only one stakeholder who is really taking care of it, and all the others they don't care about if this whole thing runs for the next 100 years. So this is where you find the added value.
Okay.
Could I comment on hello? Okay. I was given the microphone. Could I comment on the sweeping statement, industry will invest in biorefineries? The challenge is the big oil and gas, they're waiting and seeing, or probably more recently backtracking. And for the biorefinery, it's the small companies that are taking on the risk, but without the balance sheet to take it all the way through. So, of course, big oil and gas will get involved. In the US, you see that with the Inflation Reduction Act, because it's all carrot. In Europe, there's lots of stick and lots of restrictions on how that stick, sort of can benefit. So that's where policy with mandates, together with, carrots, as well as, leveraging the big oil and gas that have the balance sheets to take things forwards, in partnership with the smaller, innovative companies that sort of definitely need help in going forwards. So you need to define industry.
Very good. So for my time, I would like to thank you for how you want to make
just a comment in return. It's not obvious that somebody who is really good and expert in developing technologies is a good operator. And there's no reason that should be the case. In fact, it almost should not be the case. And I think that operating companies at the end of the day are the only answer to a sustainable biorefinery.
Thank you, Paul. I would like to thank all the speakers. I think it was clear, it was very clear that you have a strategic business in your hand. We have to survive in this world, and then we need to have products. This product has to be bio-based product. We want now or later, it's a matter of time, and you have to do well. use very well the feedstock, do well with all the supply chain, all the processing, and convince the market and the policymakers that it's a game. So I would like to thank you again, all the audience, to be here with us, and especially the speakers. Thanks very much for wonderful lecture.